Welcome to the Being an Engineer podcast. Our guest today is Rob Donley. Rob is an engineer with an emphasis on developing mechanical and electrical systems, products, and equipment, and has deep experience analyzing the commercial side of engineering, as well as mentoring and developing engineering teams, leadership, project strategy, supply chain development, and project management. Rob, thank you so much for being with us, and welcome to the show.
Thank you for having me.
All right. So what made you decide to become an engineer, Rob?
Honestly, it's probably an answer that you get more often than not. It all began with Legos, really. You begin. You begin building things, and you learn the process of iterating, and then coming up with your own designs and making improvements on what you saw, testing those improvements, and then trying them out. So I would say all of us that started building Legos are very well versed in that entire process.
Absolutely. So, okay, you started building Legos, I'm assuming as a kid, 5, 6, 8 years old, whatever. And what was it about that process that you liked so much that, eventually you thought to yourself, okay, I'm going to take Legos to the next level and, start building actual products by being an engineer?
I think the progression is you start building, it's very like a pixelated experience in the beginning. You don't really have the Technics blocks where you can explore rotary motion yet. You can only build in the X, Y, and Z dimension linearly. And so you understand that there are a lot of design constraints that you're presented with regard to problems that you want to solve. If you can only do if you can only work in those three dimensions. So after that, when you get into, the rotary stuff that was included in the Technics set and motion power, it just all builds on itself. So after that, it becomes remote control cars, and then doing the same thing, iterative design process. How can I take what the problem that someone tried to do and solve it in a better way, either for higher performance or in a simpler way, which is often the best design mantra there is. So, building on that's why I went to engineering school.
What were some of the iterative platforms that you used between Legos and college?
Geez, it probably came down to RC cars. Okay. I was very involved with gas and electric RC cars, and changing the radio systems out in them to see if I could increase range, adding channels so that either the car or an airplane could perform new functions, and then changing things like, in one instance, I just about doubled the power of one of my remote control cars as a side project for fun. And the lucky part for me was that I had parents that supported that development. They considered it my tinkering as part of my formal education before I got to school. So it was, I went into engineering school with a very practical background.
That's fantastic. I love hearing that your parents supported that. I have a few children of my own, and at least one of them is definitely interested in engineering. So I try and foster that wherever I see the opportunity. What were some of the things that your parents did that helped you feel supported in developing that skill set?
I think a major one for me was, I guess, another hobby that I had in model rockets. And so when you start building model rockets as a kid, you're generally looking at the Estes sets that are for sale in a hobby shop, or now probably bought on Amazon. And you understand, after building a few of them, how they were trying to solve the same problem over and over again. And my dad got involved with one with me where we talked about the ideal way to make high-strength glue joints, and taking a look at how to make very strong rocket bodies. And that started a discussion. I mean, I was probably 10 years old at the time, about why wrapping paper tube is twisted in a helix like it is out of a piece of paper, and it makes it a very strong object. And so, after that conversation with my dad about why glue works and what are the weaknesses and strengths of glue, we built a rocket of our own without a kit, and it was great. It had a great flight pattern, good maximum height, it was very strong. My mom probably tossed it when I was, in high school, but it was then that I learned that there is always a better way to do something, and that I think has kept my passion going. And especially once I started connecting this kind of design thinking to medical devices, which is in the main industry that I operate in, there is always a better way to push a medical device design forward, or to further the industry as a whole in the state of the art. So,
How cool. What a great experience. Was your dad also an engineer?
he was a petroleum refining engineer and chemical engineer. Went to the same school I did, went to mines, and had kind of always had that Nick, had the knack, tinkering mindset. So I think he was excited to see that in me, although I was into probably different things that he was. But the important part about my development was that he was interested in what I was interested in and showed me better ways to do it. And that sort of started the gears turning.
That's a huge deal. I consider you very fortunate to have had a father who is interested in the same things, because speaking as a father, it can be tough to be interested in the things that your kids are interested in. I can only hear so much about Minecraft and building in Minecraft and the video games that they're into. Um, let's talk about the School of Mines, where you graduated. You just mentioned that. I guess your dad went there as well, which is cool. You've got kind of a legacy now at that school. I had a friend quite a while ago who also went to the Colorado School of Mines, and he was so excited about attending this school. Tell us what's different about the School of Mines from other universities out there.
I think, for one, a lot of the professors come from industry, so they have a practical knowledge that connects with theory that you read in books that I didn't see elsewhere to the same degree. To be fair, I think some of the other Colorado universities have fantastic engineering programs. CSU and CU in particular, just really strong stuff. But for me, mine, smaller school, more attentive. In terms of the student to faculty ratio when I was there, at least in the specialized classes. You're going to be in a room with 100 people for Calc 1, no matter where you go. But once you get to, something like super strengths or, like a vector mathematics or something, you're likely going to be in a room with 10 people, and the professor generally can, check up and care about your learning more. So I think school size was important to me. That industry experience was important to me. And then Mines is generally known for, I don't know, some people would call it mindsifying a problem, but breaking a problem down into its parts in terms of the math and understanding the science before evaluating and proposing a solution. So instead of just going into a problem, where there's a textbook definition for it, one of the things I enjoyed the most was, what if there isn't an answer for this? I did a lot of work in fuel cells my senior year at Mines in the Colorado Fuel Cell Center under Neil Sullivan. And a lot of things we just didn't know because the technology was still being developed. And so one thing I liked about the Mines experience was trying to quantify what you don't know in terms of math, and then find out what you want to know that you don't know that matters to a problem. And that whole approach was something I found, reiterated all over my mechanical engineering experience at Mines.
I'm getting a sense for the process that was taught at Mines as you talk. When I graduated college, certainly I had a foundation, an engineering foundation to build on, but I don't think I was extraordinarily useful to the first company for which I worked, right? I just didn't have that much experience, and there was a lot of on-the-job training. Graduating from Mines, do you feel like you hit the ground running at your first full-time job? Was it a better environment in which to learn the what's the word I'm looking for? The skills that make you actually useful in an engineering company?
I can tell a story about that. When I was in college, I ran a landscaping crew in Denver and Greenwood Village, and I remember the day I was at a mansion in Greenwood Village in Denver, digging a new ditch and trying to find a tree root that had clamped over a landscaping sprinkler line. And I got a call from my senior design professor, literally, soaked in sweat. It's 105 degrees out. I'm holding a shovel. And he says, hey, I've got the president of this company in our research lab right now, and he's looking at the test station you designed to evaluate the performance of fuel cells, and he wants to offer you an internship. How does $20 an hour sound? And I mean, I think my boss could hear the shovel hit the ground. And he said, hey, no hard feelings. I hired you knowing this day would come.
Oh,
So
funny.
I would say, how applicable was it? On the first day of work that I got to that internship, he said, your job is to recreate what you did.
Wow, that's fantastic. So what did the School of Mines do that fostered this ability to do, industry specific work, as opposed, I mean, I did a lot of labs when I was in college, but I can't say that many of them were applicable to anything I did directly in my career.
So I think it all starts with the EPICS program when you're in freshman and sophomore year at Mines, and you learn about, actually making a product or device that solves a problem, whether that market need be for consumers or private industry. In this case, it was private industry research that was, ultimately going to end up in a consumer product. And so it starts there with, on a very small scale with sponsored projects about how about you identify a problem that we see and see if you can propose a solution to it. We'll do like a viability study. Once you get to the senior year at Mines, you're expected to do a senior design project, which is sponsored by any of the research professors that are there, local companies in the area. CU has a very similar process, and they give you a real problem to solve and say, we're going to put 6, 7, 8 of you in a room and give you essentially all year, two semesters to do it. And the first semester will be planning, and the second is execution. And these are your deliverables. And so for me, it was pretty easy. You basically get to choose from a list, and they have like a community outreach program to get new projects signed up every year. I chose from a list, and my project that I was assigned to was in a graduate research lab at Mines. There's a branch under it called the Colorado Fuel Cell Center that was ran by one of our fluids professors, a great guy named Neil Sullivan. And I was put on a team of 6 people to solve a problem for them. And
you did?
And I did, yep. We did. Well, I should say we did. Everything in this game it takes a village, and especially in regulated industries, it takes a village.
Yeah. Well, we've worked on a training program here at my company, and kind of the motto that we have is doing is better than learning about doing. You can only learn so much from a textbook, and then it's time to just jump into it. I remember I had an internship as I was finishing up my master's program, and one of the things they had me do was build a test fixture, not just design it, but actually manufacture it. And they had a manual mill and a lathe in the back, and I got to make all these parts and put some knurls on the knobs and assemble everything and figure out what didn't work. And that was such a phenomenal experience. Doing is better than learning about doing, right?
I think that is a really good experience. I've had the experience of hiring people who I've seen that do not have that practical connection. And you could tell them, hey, we want to make something out of stainless steel or aluminum. And they wouldn't understand that you would likely have to anodize aluminum, whereas you wouldn't with stainless steel because it doesn't require coating for a lot of applications. Or what a Phillips screw is. Ask someone a question, how are you going to secure this to that? And so I think it's great that you got that practical experience of we're going to build something and put it together and then learn about what we did wrong and then build it again,
right.
And iterate. That's really important to fixture design as well. So I think that's great. So
it's ironic that the project I was given back, this was probably, 16, 17, 18 years ago, but now that's mostly what we do is test fixtures. So it's kind of feel like it's come full circle in a way. Speaking of doing something and then learning what you did wrong and improving that process, one of your previous roles was leading Kaizen change teams to streamline engineering and operations processes. And I think we've all heard the term Kaizen, and kind of have a rough idea for what it means, right? It's something within the context of manufacturing, but I don't think that a lot of us understand the details. Can you walk us through the Kaizen system and how does it help operations and manufacturing?
So and this is a great question. What I think is interesting about Kaizen and its adaptation is that everyone thinks that this is just a lean term that only applies to a manufacturing line, like in a Toyota plant. What people don't realize is that Kaizen can apply to a sales group. It can apply to how you run accounting operations, finance. It's an amazingly powerful change system where you go and see the process and then map it out and then determine where there is either wasted time or communication. And in a sense, I could tell you a story about when we did it at a previous company for a sales order process. Generally, if a customer comes to a company and says, "Hey, I'd like this widget to be produced, and it needs to look like this and be this big and be made out of this material. How much will it cost, and when can you get either prototypes to me or something I can see so that I can approve the design and we can move forward?" Think about how many hands that has to go through to have something happen like that. I mean, first of all, you have the salesman on the front end who is the customer contact likely and says, "Okay, I need to understand what it is the customer wants. Then I need to relay that to an engineering team who's going to relay the cost of that to either an accounting group or somebody perhaps in a project management office. And then they have to relay that to someone who's actually going to build a prototype or the device to make sure that the cost is in line and time. And as an engineering department or a manufacturing company in general, you're selling capacity. So where does this new project fit in the grand scheme of all of the other stuff that you're doing? So when you look at all of the hands that the incoming request needs to be tended by, you can start looking at, okay, job one was salesman gets an email. What's his next move? Is it the right one? Should he be copying multiple people at once to kick off a project? Should there be separate engineering resources to handle something like make it, move it in that sense? Can we have someone who has 10% of their time reserved just for stuff that comes in the door? Because especially this day and age, customer response time is paramount. If you're not hungry enough to adapt your own processes to get back to that request as fast as you can, faster than the market can, someone else is going to eat your lunch. So with this Kaizen event, we took the essentially quote time and some initial CAD images and things like that of a concept for a customer to approve from about 2 weeks down to 48 hours.
Wow.
And mind you, nobody was doing any additional work. We were just changing what they did and when.
Huh.
So that's a very powerful tool.
That's amazing. So would it be accurate to say that Kaizen, it's this is, like you said, not specific to manufacturing or anything. It's more like just a process improvement process or system?
I would say yes.
Okay. Where can people learn more about Kaizen? Is there a formal course that one takes, or do you just search the internet and look for some kind of manual?
It's well documented everywhere. You could go on YouTube and start looking at how do I do a Kaizen event, or however you want to do it. But it's very well documented in a formal lean training setting. So any of that will have a strong tie to Kaizen and Gemba, which is the Japanese word for go and see. It doesn't count to just talk about something. You have to go live it and be there before you change your process. I think that's very important for companies to consider, especially people that are in process change at a company. They need to be out on the floor, be seen, and be talking with the people who are doing these processes 8 hours a day, rather than speculating on them from their air-conditioned desk.
Doing is better than learning about doing.
Well, and then if you follow Bloom's theory of taxonomy, Bloom's taxonomy of learning, it would say that the highest peak of that is then going and teaching someone. So the idea is Once you think you know how to do something, if you can teach it to somebody else, then you've mastered it.
Have you ever built a test fixture that didn't work well? Most engineers have, usually because of hidden pitfalls you wouldn't know to look for if you don't design fixtures all day. After watching this happen for years, we built a simple 5-step framework that gets fixtures right the first time. And we packaged it in a free guide called The Essential Guide to Designing Test Fixtures. If you want more accurate, repeatable data and fewer redesigns, grab the guide at pml.engineer/test-fixture. Get it, steal the framework, and level up your fixture game. You are making these perfect segues into all the different things that I want to talk to you about. And there are a lot of things that I want to talk to you about. But one of them is mentoring. You've done a fair bit of mentoring of junior and senior engineers in your career. What are some strategies that you found to be especially useful in training other engineers? For example, if I were a junior engineer, what behaviors or habits or practices would you suggest that I develop to accelerate my skills?
Let's focus on the idea that everything in a regulated industry, and I'm sure if you're designing testing equipment, you're operating in regulated industries, takes a village. So what do you think is the most important thing, the most important skill you could have when it comes to getting something done?
Are you asking me?
Yeah, knowing that it takes a village.
The important skill, I would say communication is key. You need to know how to talk to people.
So that would be where I would start with most junior engineers and say, do you know how you're sending a message to somebody else? Or if they've received it correctly, do they understand? Do you understand what their request is? And is everyone in alignment on moving forward with something? There are so many details to what we do. Communication is just absolutely paramount. And if one of those balls gets dropped, it could be like a negating factor for releasing a product to market. And so I know that that's probably not the answer that many listeners are going to want to hear me say, is that engineering really isn't about the engineering. It's really about people. But it is. It's really about, on a very basic level, it's about people. People's ability to problem solve is amazing, especially in our economy, and their willingness to think and go outside of the box. But if you can't share your ideas with someone else and get them to help you over, some stumps and generate that understanding, ideas go nowhere.
Do you have any stories that you can think of and share with us where good communication led to a really positive outcome, or conversely, poor communication led to an abysmal outcome?
Oh, gosh, I would say all the time. I'd have to think of the story of a story here, because there's stories for both.
We can come back to it.
Let me think about it.
All right. Well, while you think about it, I'll just take a quick break here and remind our listeners that the Being an Engineer podcast is powered by Pipeline Design and Engineering, where we work with predominantly medical device engineering teams who need turnkey custom test fixtures or automated equipment to assemble, inspect, characterize, or perform verification or validation testing on their devices. And you can find us at testfixturedesign.com. We're speaking with Rob Donley today, whose current role is as a project manager at Terumo, leading medical device engineering teams, but we haven't even gotten close to that point yet, because there are so many other questions that I want to ask, predating his current role. So kind of diving back into that, actually, I'll give you, did you think of something that you want to share? If not, I have plenty of other things to talk about, but I'll give you a chance. Did you think of anything, a story you can share?
Sure. So there was I guess I probably shouldn't name the company. So in a former role, we had a field action issue. So whenever in the medical device world, whenever something goes wrong in the field, either with a patient or out in a hospital, outpatient clinic, something, if something goes wrong with a product and it didn't work as it was intended to, you usually get a field ticket about it, or some kind of action request. And what was interesting, we got word that an anesthesia tube set was leaking, and it was only in certain parts of the world, but no one had collated this yet, or thought to. And essentially, it was letting excess oxygen into a anesthesia circuit that shouldn't have been there. So you didn't really know if the patient was getting good, positive pressure ventilation or not. So we began a root cause investigation, as you would with any problem that's reported. And we were looking at all kinds of things, like, did something go wrong with the glue? Did something go wrong with the plastic? Was it something that we controlled inside of the plant? And communicating with another team of interns, we had decided that, maybe it's something that happened outside of the plant. So we started looking into the data, and when you have that many people looking for an answer, people need to be strategized and looking for things in the right places. So we had a big group meeting and said, okay, we want someone to look into where all of these failures occurred. We want someone to look into, is it in the same hospital chain? Is it a geographic problem? Did they all leave one warehouse? Is it something that's happening in one warehouse? Start looking for common factors. So you generate this list and then divide your resources instead of let people sort of work off in their own silos. It worked really well, because what we end up finding from someone who did some data analysis was it was only happening in Arctic regions of the world. And so what would you guess happened to the plastic that made up these anesthesia tube sets if it was in a cold region of the world?
I'm guessing.
Go ahead, yeah.
I'm guessing something related to elves or Santa or maybe cold.
The idea was maybe they unloaded some of these boxes from a plane and left them on a cold runway for a while before bringing them into the hospital. And what would happen if the plastic froze? Yeah. So that was a great idea. So we said, okay, let's spool up a team to evaluate this, and we put some of these products in an environmental chamber, and it turns out plastic cracked when it was frozen. So now we had it.
Interesting.
So if we didn't take the time to organize the resources in the ways that we did, so that everyone understood that the goal was understanding what was causing this, and that we were now looking outside of the factory, we'd probably still be looking for the problem.
That's a terrific example. Any other communication strategies that you can share? I mean, you mentioned that if you're mentoring a junior engineer, one of the first things that you're going to hit on is effective communication. What are some tools or strategies that you have shared in the past with engineers to facilitate better communication?
I think when people are not responding in the way that you need them to, or in terms of helping you or the organization, it comes down to three things. The first is they don't know what to do. Are we clear on what we need to do? And the second is they don't know why it's important. How does it fit into the greater picture? And the third is they don't know how to do it. And so if you, and people in general want to do good jobs. They don't want to be bad at what they do, but they get reservations if they feel vulnerable for admitting that either they don't know what to do, why to do it, or how to do it. And so if you focus on those three things with most people, and every time you have a communication interaction with them, it generates a lot of alignment and clarity.
What, why, and how? Yeah, I love that. I have found as a business owner and team leader that oftentimes, maybe even most of the time, when my expectation for a team member is not met, it's usually because I haven't defined with enough clarity what was expected from that team member. Not because this individual didn't do a good job or was lazy or was slacking. It usually comes back to me as the leader having not defined clearly enough what was expected of that individual.
There was a time in my life where I was not so self-aware, but now that I've looked back and on all of the, critical conversations that I've had I known that 10 years ago, that would have been very important to my career development. And so that's something that I share with people that I mentor today.
Just providing clarity on expectations, you mean?
Yeah, that's the way to get things done the first time.
Yeah, Yeah. And it's hard to do that because we're all busy, right? And it's so easy to just kind of assume that someone else knows what you expect, and B, assume that you yourself understand clearly enough what you want to happen. I find that oftentimes I'll assign a task to someone, and then I'll think about that again and realize, I don't think that I'm 100% clear on the outcome I want. And I'll have to go back and revisit that task and talk to the person and say, hey, apologies. I don't think I was 100% clear. Here's what I really want to happen. You probably never experienced that, though.
all the time. The easy way out is say, you tell me what you want to do. But, I think unknowns in science and technology development are always going to exist. So you can't expect to be perfect. And you're going to get a new set of data that changes the way you think about something every day. So you may think that you had the best idea about what to do yesterday. And then today you say, wait, this changes everything. So I think, I think in your case, then relaying that to people or letting them have ownership of those tasks is a very powerful and empowering thing too.
Yeah. Well, speaking of improvement and clarity, one of your skills seems to be finding ways to reduce operational and manufacturing costs. Can you run us through an example of how you did this and maybe share some best practices that the rest of us can use to look out for these types of opportunities?
Sure. So, in manufacturing, you're generally looking to do, at least stateside, you're looking to do the highest value processes that you can and eliminate low value processes because it's very expensive to manufacture in the United States. And so with that, let's take the example of an electromechanical machine. Let's say it is let's say it's the Coke Freestyle machine. Have you ever been to Noodles and Company or one of those restaurants that has that Coke machine that's big and red, and it was designed by the same group that does the industrial design for Ferrari, and it has the big digital screen on it, and you can click whatever flavor that you want in combination and add it to your soda.
Yes, I know exactly.
Have you ever seen one of those?
I have.
You can imagine how many electrical connections are behind that screen that go to all the motherboards, all the circuit cards and different solenoid valves to control fluid flow and mixing valves and all kinds of things, that go. So let's take, for instance, and this is relating to COGS, cost of goods sold at the end. Let's take, for instance, you needed to wire that machine. Let's see, the first generation of that machine, you have someone taking wire off of a spool, splicing, cutting the insulation off of both ends, crimping on a connector, and then connecting, let's call it 300 connections one by one. Let's say that it takes them 5 minutes per wire to pull the wire out, measure it, cut it, splice it, put maybe it needs to be heat shrinked again for electrical insulation, and then installed again, and then check to be sure that it's right, because there's a human factor to making sure that all 300 wires, if they're identical, got to the right place. So let's model a factory in the United States at about $4 a minute for assembly. So 5 minutes times $4 per cable is $20, times 300 cables is $6,000 to wire that machine. And that's just to get all the connections made. Okay, so let's go to a house that has an automated cable harness assembly system, somebody like KSI, I think is a company we've used in the past, and say, okay, we would like you to prefabricate us this wiring assembly that has all the wires already done, and they have basically like a computer-controlled robot that can do most of this, and then some hand assembly. And they'll come back and say, it's going to be $1,500 to do that. Okay, so then we take a look at how long an assembler would take to take a $1,500 wire assembly and wire up a Coke machine. Let's call it takes them 20 minutes to put the whole thing together. The cost savings is unreal in terms of cost of goods sold. You've just cut it in half. Yet you would now have to convince a buyer who works for your company that it's okay to spend $1,500 on a wire harness assembly because you'll save it in labor on the manufacturing floor. And what can often happen is they'll say, well, that's in a different cost center than mine, so why do I care? So you have to, it is a politics thing. But when it comes to device design, you want to think about this stuff before you send a product to the floor. You want to eliminate as many manual processes as you possibly can and get really to just putting sub-assemblies of things together, because that's the higher value work. You saw that done 20 years ago in the appliance industry when everyone moved to Mexico and essentially had sub-assemblies built there, and then all they do in the U.S. so that Maytag can put a Made in U.S. sticker on it is slap the assemblies together and put the door on. They're not running any wires in Wisconsin. So that's part of the thinking of taking a lot of cost out of designs is not just looking at the cost of the component itself, but the cost to assemble it. Then you could take that to a third tier in the Design for Excellence school of thought, which is how does the design that I've just produced not only impact how it is manufactured and costs that way, but how much does it cost to be serviced? If you put a blind screw, like for instance, the heating element in my dryer just went out, and I needed to test and identify that was the problem and replace the heating element. Terrible design by the dryer by the dryer manufacturer that I had, because to remove the heating element, which you would think is a serviceable component like a light bulb, there was a blind screw. So it's a screw that you can't see, and it's backed around a corner inside the unit. So that design introduced a complication for any service technician who's going to try and service that machine. So when you think about the total cost of a product, it's not just manufacturing it. You also tie this into the cost of servicing it in the field. You need to make all that stuff easy to do and not take very much time. So I guess that's a long tangent on a story that's relevant.
No, that's a perfect example. Thank you for sharing that. And as you spoke, I could hear, I think, not being an expert at all in Kaizen, but I could kind of hear the Kaizen methodology, right? As you were going through that, breaking it down into smaller chunks and identifying where the waste is and stripping that out. That was really great. What's been one of the most challenging or interesting or fun projects that you've worked on in your career?
I think one of the most fun things that I worked on was a genetic diagnostics machine that was originally invented by four biochemists in a garage in San Jose, California, and they had this wonderful experiment where they were using an enzyme essentially to attach to target species of bacteria, and they were using I guess when it comes to like analytical biochemistry, what you're looking for to prove that someone's infected with something is a threshold that you have to see. So like let's say I swab your throat for a strep, and I swab it on a dish, and I have to wait for it to grow. Well, I have to wait the amount of time it takes to see the minimum threshold of detection on that plate, which is likely visual or under a microscope. And that's really the problem with most like hospital installed systems that do diagnosis. So anyway, side tangent about explaining the market need. We don't want to wait 5 days for results. We want them in, an hour or 6 hours. How do you do that? How do you lower the amount of the colony that is needed to be able to detect what it is with a good amount of confidence? So they invented this process to do this chemically instead of visually through a microscope. And so you have a enzyme that latches onto a target pathogen, and if the enzyme is connected to the pathogen, then it becomes excitable by a laser light that is shined onto it.
Okay.
And you're using a clear test tube. with the sample, this enzyme that is looking for a target species, and the laser light. If you see a reflection in a digital camera, then you know that the target species of bacteria is present. And depending upon the intensity of that reflection, you can know how much of it is there. So this was and then likely the second part of this is you could administer a treatment to that same test vial and see if the light reflection goes away. And if it does, you know that the enzyme detached from the pathogen because the pathogen died or is now inactivated. So they developed this for 12 different pathogens, and the test time was down to about 3 hours to identify, and another 3 hours to prove the effectivity of a treatment. Unbelievable stuff, using laser reflectance to look at whether or not these enzymes were attached, and they could administer 12 enzymes to the same sample. And depending upon the color wavelength they saw back, they could identify what happened. And it was originally developed to diagnose superbugs. Interesting story about this. What they hadn't realized was that they thought that their customer was hospitals in terms of, how many stories have you heard about people getting the wrong prescription or a prescription that's ineffective, and then by the time they needed to be healed, now things are really going downhill.
Sure.
So they thought that was the problem they set out to solve. They were called by a huge pharmaceutical conglomerate that said, "Hey, we want to pay you lots of billions of dollars to have this because it's the fastest way that we have to prove the effectivity of our new drugs against superbugs." And so, they thought they were solving a diagnosis problem. What they were really solving was an analytical chemistry problem. And so these guys ended up selling the company, and the product is being made today. And it was just a really great beginning to end of seeing how the science started, how this started to develop into a patient system where they wanted to do 12 patients at a time in the system, and then how the real market need for this product was it was still needed in hospitals, but a much bigger market need was in the pharmaceutical research industry. And I think that's important to think about, and a really good lesson. This lesson is one of those that has a happy ending, but in terms of entrepreneurship, 92% of startups fail, and the largest chunk of those, 43%, is because the wrong market need was sought after with the solution.
Yeah, that's a whole other podcast, figuring out how to identify your target market.
Yeah,
that's a big question. It makes me wonder if that technology is being used right now to combat COVID.
They are developing a test for COVID, and I think they already have been. And that is pretty great. It is pretty cool, but I think this is at the bleeding edge of the state of the art, and it was released maybe a year ago for its clinical trial. So the system's really not in the field yet.
Interesting. Okay. Huh. Well, we'll kind of wrap it up here. I mean, in all honesty, Rob, I have not gotten through. I maybe got through a third of the questions that I wanted to ask you. I might ping you again next year or something to see if you can come back for a repeat appearance, because there's so many things that I really would love to talk to you about. But we're getting towards the end of our time here, and we both have things that we need to do. So let me ask just one or two more questions. What are some of the biggest challenges that you face in your job each day?
A really big challenge for me is the unpredictability of supply chain. So once you have a design release to field, or once you have a design release to a manufacturing floor and a product that goes out to the field, and you're expected to make, let's say, thousands of these products, so you're making several hundred of them a month. What happens if a supplier is late on a component that you need for whatever reason? Could be a global pandemic, could be a hurricane, could be their factory burned down, which literally just happened to us. What do you do? You have to document any change that you propose if you're going to use somebody else's widget in place for a while under like a temporary engineering change notice. You have to test that, plan test it, move it. I mean, it creates a ton of churn to a process that is supposed to be stable. A lot of people think that the finish line for product development is once you throw it over the wall to manufacturing. That's a terrible view of the world, because manufacturing is going to have constant problems that were not anticipated by either group. And supply chain is probably the one that bites manufacturing the most.
Yeah. Yeah, I find the same thing to be true. We work with some inventors, and it is so hard to communicate the fact that once you finish development, the project's not done. Exactly what you said. There are all these things that come up in manufacturing that no one anticipated, right? This is the first time that anyone in the world has made this exact thing. And so problems are inevitable, and manufacturing is just like the second stage of development.
Yep.
Okay, last question here. You have a really interesting, I'm going to call it a scribble, and I'm probably not doing it justice, but you have a scribble that you use as the background image on your LinkedIn profile. Tell us about that scribble.
It's something that motivated me, and actually I can't take credit for it, so I should give credit where it's due. This came out of Stanford's engineering school, and I believe it was Stanford's. And the idea is that when you're doing concept convergence, you're looking at the market problem and saying, oh, maybe if a product had this, it would be really great. Or maybe if something had this. And a lot of people want to go right to design without thinking about what it is they're designing. If you look at that image, it shows that there is a clear phase for concept development and then a clear phase for design. Once, the corners of your solution have been defined. And then if you go in with that kind of focused vision, then what you end up with is a quiet and smooth or a quieter and smoother development process as you go through like alpha, beta testing, product testing, and then finally release for manufacturing, transfer design. So I really liked the flow of that image of thinking, like you've got a CEO or president coming in saying, what if we could do this? What if we could do this? What if we could do this? What if it does that too? And you sort of frame that up into what a product actually could be and determine what is important and boil it down to its essence and then execute instead of trying to execute on all of these concepts at once. So it's a very, to me, it's a very calming image in terms of design thinking. And I think it's called the design squiggle is the name of it.
I was close, not scribble, but squiggle. But sometimes you're working on a design, and even if you've done a lot of the research and the back-end work to be pretty confident in the concept that you move forward with in development, you reach a certain point and maybe you realize, well, shoot, this isn't working out the way that we thought. So you have to still allow for the unknown, right? For these problems that arise that no one could have foreseen, and maybe you have to go back and back to the research board at that point, right?
Yes, you do. But I think that there's a difference between chasing every wild idea that you come up with, and then having a strategy about executing on a few and allowing for those unknown things to come up. You're absolutely right to point out there's a lot of things that we don't know when we get into this.
Yeah. There's a quote that I have on my wall. Actually, I'm going to read it right now. It says, "Success isn't that difficult. It merely involves taking 20 steps in a singular direction. Most people take one step in 20 directions." That was from Benjamin Hardy. Willpower doesn't work. Anyway, I've always loved that quote, always. I've only had it for a few years here. But I think it relates very directly to what you're saying, is that we're always going to have a lot of different ideas that we can pursue. And we could take one step in 20 different directions, but it's probably not going to lead us to anywhere very fruitful, versus picking one or maybe even two of those ideas and taking 20 steps in one direction or 10 steps in two directions. It's usually a much better strategy.
One of the best pieces of advice I've ever gotten was learn how to say no quickly. And I apply it to this. No, we're not going to do that. No, we're not going to do that. Yes, let's do that, So.
Well, I'm very grateful that you didn't say no to the podcast.
Thanks.
So I think that's probably it for now. We should wrap up. How can, speaking of the LinkedIn squiggle that you have, how can people get a hold of you?
LinkedIn's probably the best and most convenient way. I'm Rob Donley on LinkedIn. I think it lists that I have a professional engineer license and an MBA on there too, so you probably can't miss the name.
Excellent. Well, Rob, thank you so much. Again, there were so many questions. In all honesty, I think I had more questions ready to ask you than anyone else I've interviewed to date. So that probably just says a lot about you and all that you've done and all the experience and expertise that you have. So thank you for sharing that with us today on the podcast.
Thank you. Thanks for having me.
I'm Aaron Monker, founder of Pipeline Design and Engineering. If you liked what you heard today, please leave us a positive review. It really helps other people find the show. To learn how your engineering team can leverage our team's expertise in developing turnkey custom test fixtures, automated equipment, and product design, visit us at testfixturedesign.com. Thanks for listening.